Hi there. In this tutorial, we'll cover how you can integrate KitOps with KServe. But first, let's also understand what exactly is KServe. It's an open source platform that allows for easy serving and deployment of machine learning models on Kubernetes in a scalable and production ready manner. It also comes with a bunch of enterprise features such as auto scaling, load balancing, support for canary deployments, and it's also an incubating CNCF project. Let's take a look at a classic example of how to get started with KServe. So here we have an inference service where we are using the model format as Hugging Face. We have given it a name as arg for Qwen. And then we have the storage URI, which basically tells KServe from where it should fetch the model files that will be used for serving. So here we are fetching it from Hugging Face and we are using the Qwen 2.5 model. And we are assigning one GPU resource to our pod for doing the inference. Diving a bit deeper, so we have initialized our storage initializer here and we are fetching the model from Hugging Face and we are having VLLM as a runtime for doing the inference. KServe also exposes an OpenAI compliant API. So no need to write client apps. You can just use the base OpenAI client and replace the base URL with a KServe endpoint. But one thing to keep in mind is that whenever you're using models from Hugging Face or anywhere in the public internet, there's always an inherent security risk because these AI models and especially LLMs are like black boxes. These are these opaque artifacts. So if someone has intentionally made changes into either the training data or in the model weights or poison the model, we can never get to know. And this is a huge supply chain risk because we don't have any audit trail whatsoever. And that is why we use ModelKits, because they come with built-in attestation and you can sign the models and also use open source projects like ModelScan to scan the models for vulnerabilities. But you get full-fledged attestation for all of the different moving parts of a machine learning system because you're packaging all of them inside of the ModelKit. So what we do is that we are going to replace the default storage initializer, which is with Hugging Face or S3, and instead we'll use Kit. So if you go through the guide here, you can see that we can basically use KitOps as a cluster storage container inside of KServe to serve ModelKits directly as InferenceService. So in this example, what we are essentially doing is that when we set up our cluster storage container and we specifically define here to register the Kit protocol, this essentially means that we configure KServe to say that whenever a model storage URI starts with Kit, use the specific container image that can know how to unpack ModelKits, which is it will fetch from the KitOps storage, open them up for KServe to use the model inside. So whenever you have the model storage URI starting with Kit, it'll use this particular container image to fetch and unpack the ModelKit. And once it gets the model, it then will use for the inference. So inside of your inference service, just replace the storage URI with Hugging Face and use Kit instead. So here, no matter wherever you have stored the ModelKit on any type of OCI artifact, a registry, you can just use that instead. And you get a much more secure way to use the inference rather than using a publicly available model. You can use KitOps and ModelKit for a much more secure model inference. Let's take a look at this in action. So I have a GitHub repository here in which I have trained a model using this train_iris.py file, which is a simple sklearn based random forest classifier model. Now for this, I've also created the Kit file, which is defined here, which basically just specifies the model. In this, we have given the model format as sklearn and the path for the model itself. And you can see here the registry on JozuHub, which is also one of the OCI registries, where you can see the Kit or the contents of the ModelKit, which is the metadata, the package, and the model, in this case, the model.joblib file. Now here, we'll just quickly now take a look at our code. So I have a CO cluster, which is running a VM, and here I have KServe installed. So if I just take a look at content files here, you can see that I have the Kit file and I have the cluster.yaml. So I can just quickly also show you what the cluster.yaml looks like. So if I just open it up, so here we have our cluster storage container, which is basically telling that we'll use this particular image for being able to fetch your ModelKits, unpack them. And here it basically tells the prefix as Kit. So whenever you create an inference service, just use this to let the KServe know that we are actually going to use the ModelKit instead of your typical Hugging Face based model. And if I also take a look at the inference.yaml, so we can quickly also open it up. And here you can see that we define our inference service and we have the metadata name as sklearn_iris and we have the storage URI as this particular KitOps file. So this is the ModelKit that we have on JozuHub, the same one that I just showed you here, which is the iris test. So that's what we have used over here. Now, when it comes to actually now implementing, there are a few things, right? So when installing KServe, do ensure that you have KitOps installed because of course this will be used for creating the ModelKits and pushing them over to your remote registry. when using KServe, you also need to have Knative serving installed and also install all of the cluster resources that you need for KServe. Now, in order to prepare the model, we just run the python train_iris.py. So when you run that, we generate our model file, which can be seen here, which is this model.joblib, which was also then packaged with ModelKit inside the ModelKit with the help of the kit file. And once you have done that and you have pushed the model to Zozu Hub, in this case, we just use a kit push. Now you'll just apply the KitOps cluster container YAML. So in this case, our custom container that we have created for our cluster storage container. So we just have to apply that. So you just run this command for kubectl apply f, and we just apply our cluster.yaml. And now we go ahead and deploy our inference service. In this case, we have inference.yaml. And now we'll just wait for 10 seconds and we'll see the actual deployed service. And also we'll be able to see it here running on this particular pod. So you can see that our service is already running for the past 3 hours that was running. And this is our URL that we'll use for actually testing it out. So what we'll do is that we will test this with kubectl run curl test. So we'll run it inside of a pod. And we are running a curl request where we are calling the service with the endpoint for doing the prediction, in which we pass 2 separate types of flower information and we get the prediction as 0 and 2. So these are the classification that we have done for these 2 different test files, and we get the prediction. And then afterwards we delete that curl test pod. Once we have done our inference, we just run this inside of the pod and get the results. So this is a classic example of, you can see that instead of using a Hugging Face based URI, we are using our model and we are calling it from a ModelKit, which is a much more secure way of doing that. And if you want to dive a bit deeper here, you can see that we have the instructions on how to install the cluster storage container and using the ModelKits as the inference service. You can also have proper registry credentials. So by default, the KitOps container will use the kit user and kit password to log in. You can also inject those with the help of a Kubernetes secret. Or if you're using AWS ECR or GK, you can also set the specific secrets over there instead of having to use like the default kit user and kit password. So that's a quick tutorial on how to get started with KitOps with KServe, where you essentially use KitOps as your cluster storage container and swap the default Hugging Face or S3 URL with the help of the ModelKits that are being stored. And this allows for much more secure inference by providing the AI models which are secure, they have been attested, and can be used for much more secure deployment of your AIML systems in production.